Lockheed Martin is developing a next-generation nuclear reactor-powered spacecraft for the Joint Emergent Technology Supplying On-Orbit Nuclear High-Power Program. Welcome to the Space Diary channel. Before watching, I want to ask you to help our channel by liking and subscribing. Lockheed Martin is developing a new type of nuclear-powered spacecraft that will allow it to reach planets and other bodies beyond Jupiter much faster. Scientists are launching more and more spacecraft beyond the inner solar system. New missions are also planned in the future to explore planets and other bodies beyond Jupiter. But the duration of such flights is years, and sometimes even decades. That is why engineers from various private companies and government agencies, particularly in the United States, are developing a new type of space engine that would speed flight times. Modern rockets with chemical engines and solar-powered vehicles can no longer fully support deep space exploration missions. The limit of their capabilities is a flight to Jupiter. The devices and spacecraft that need to be sent beyond this planet must use nuclear energy in one form or another, as scientists now believe. They will be able to reach their targets in the outer solar system faster, while chemical-powered launch vehicles can propel the vehicles only due to their small size and the use of gravity maneuvers. All this takes too much time. Lockheed Martin engineers are in the final stages of developing their new nuclear-powered spacecraft. The engineers want to combine a nuclear reactor with electric motors, powered by the Hall effect to create thrust in the new spacecraft. According to the current design, a nuclear reactor will be placed in the body of the new spacecraft, followed by electric motors. The scientific equipment itself will be placed further on a special extension arm to protect it from the nuclear energy source. The new reactor will be built using technologies used to create Stirling engines. The core will have a diameter of only 15 centimeters and will be surrounded by a beryllium oxide reflector. Uranium-235 is to be used as fuel. The principle of operation is as follows. One boron carbide rod starts and stops the reactor, and the reflector catches the escaping neutrons and reflects them back into the core. For safety reasons, the reactor will not be put into operation until the spacecraft reaches a safe orbit. After launch, the reactor's heat will be used to power a series of Stirling heat engines, which work by compressing and expanding gas in a closed cycle. This will generate up to 20 kilowatts of electricity, which is 3 times more than the solar panels of current spacecraft. This would not only greatly expand the life of deep space probes, it would also power the Hall thrusters, which can slowly but surely accelerate spacecraft to velocities great enough to escape the solar system or allow the probe to visit a wide variety of potential targets. According to Lockheed Martin, the energy generated will drive the engines that operate on the Hall effect, which will slowly but surely accelerate the spacecraft to a very high speed. This will allow the spacecraft to quickly reach its targets in the outer solar system and, if necessary, even leave it. As a result, the flight time of the spacecraft will be significantly reduced.